Hi everyone. Today we're going to be looking at the square root of a number. So in your notebook, please put today's subtitle, Square Root of a Number. Well, at this stage in your math careers, almost everyone knows the meaning of the square root of a number. The square root of a number has the following definition. The square root of a number is equal to a result such that the result squared gives you back the original number. Here's a very elementary example. The square root of 36 is equal to 6 because 6 squared gives you back the 36. Now, for some of you who may have had experience with quadratic functions, you may have also been required to consider that square root of 36 is also equal to negative 6 because negative 6 all squared gives you back the 36. However, in the purest definition of the square root of a number, please do not consider the negative version as a response. And when we focus more on the square root function itself, you will see why we do not consider the negative version as a valid response. And from your experiences with square roots in the past, you may already know that the square root of a negative number does not exist in real numbers. Now, despite your past experiences with square roots, you may not have studied the properties of square roots. So in your notebook, I would like you to put the subtitle, Properties of Square Roots. The first property is a very easy one, and it's one that I just mentioned a few moments ago. So property number 1 is the fact that the square root of a number should always realistically produce a positive number, including 0. The second property is more interesting. The second property states that the square root of a product should always equal to the product of the individual square roots of each item. Here's a quick example to show this property in action. Suppose I ask you to calculate what is the square root of 4 times 9. Well, straightforward calculation provides that this is equal to the square root of 36, and that is equal to 6. Now let's make the same calculation, square root of 4 times 9, but using the property. So the square root of 4 times 9 should equal to the square root of 4 times the square root of 9. And when you simplify it, that gives you 2 times 3, which is equal to 6. And finally, the third property of square roots states that the square root of a quotient should equal to the quotient of the individual square roots of each item. Here's a quick example to show this property in action. Suppose I ask you to calculate what is the square root of 9 over 4. Well, that will equal to 3 over 2. Now let's do the same calculation using the property. So the square root of 9 over 4 should equal to the square root of 9 over the square root of 4. And that gives you 3 over 2 once again. And these are the three main properties of the square root of a number. To finish off the lesson, I'd like to highlight one humongous danger associated with these properties. So in your danger color, please put down danger. And a danger involves the following. The square root of either a sum or a subtraction. Many students mistakenly believe that this equals to the square root of x plus the square root of y. But in fact, this is false. These two expressions are not equal to each other. And here's a quick example to highlight this danger. Suppose on one side, I asked you to calculate what is the square root of 36 plus 49. And on the other side, I asked you to calculate the square root of 36 plus the square root of 49. I will demonstrate to you that the sides are not equal. Let's take a look at the left side. When you simplify it, this gives you the square root of 85. And the square root of 85 is around 9.22. Now on the right side, we have the square root of 36 is 6. The square root of 49 is 7. And therefore 6 plus 7 is 13. You can clearly see that the sides are not equal to each other. So be very careful about this danger. And that's all there is, ladies and gentlemen, to the properties of square roots.